Hi Year 13, this is a video that's going to help you prepare for paper 1, your first product design paper, which is coming up this Friday, isn't it? 1st week back. This is the Beastie paper. This is 2.5 hours long, and I wanted to put this video together just to give you a little bit more guidance and just reassure you a little bit that you've been hopefully revising the right things. If you've done no revision up to now, like, you're going to have to really cram it over the next few days. I gave you this list. Okay, it's the first thing I kind of want to remind you of. This is on the VLE, and I also gave you a paper copy. Now, this list, like I said to you when I gave you this list, I've been quite nice in places. So, for example, here and here, I've been really specific about the things that I want you to know, and you can almost predict the question here of what's going to come up. But in some areas, I've been a little bit meaner, getting you to revise entire sections of materials and all sorts. Now, I'm not going to talk for very long about that, but it's going to be an advantage for you to do as much revision now as you can, produce as much revision resources, flashcards, mind maps, all of that stuff you should be keeping and using in the summer when the exams start. So I'm going to go through the revision list, show you the pages in the book that you've hopefully been covering. If you haven't been reading these pages in the textbook, then like, come on, really. Sorry, that sounded really judgy, but I'm hoping that you've had a good look through, made some notes, made some flashcards, whatever way you find best for revising. So, first thing first, can I recommend this to you? On the VLE task, the paper 1 task that I said do not mark as complete, the first video that I've put on there, you've probably watched it before, but it's this material properties one, and this one is always a really good one to just recap some of the things like what does hardness mean, what does toughness mean? So hardness, ability to resist scratching, toughness, not breaking under like an impact. So having a good understanding of what these terms mean is going to help you to answer pretty much all of the questions in the paper. I would highly recommend that you give that a look. It's not a short video, but you might want to put me on double speed and hear me jibber-jabbering away about material properties, or you might just want to have a look in the textbook. I think it's like page 1 or page 2 in the textbook. I would just give yourself a quick refresher on what those properties are. Okay, so this is the first thing that I've asked you to revise, metal processes. These are all the processes that we've had a look at over the last few weeks. Remember those fun lessons where I've got you to do a little bit of theory at the beginning of each lesson? So press forming, spinning, cupping and deep drawing, drop forging, wrought iron, we've done all of those. We've also done bending, we've done rolling, we haven't done sand casting. You do not need to know this one. Okay, we're going to cover that in a future lesson, so don't worry about that one. We've done investment casting, we haven't done low temperature pewter casting. There is not a question on these things in the exam, so don't panic about those. There is also no questions in the exam about welding, because we haven't covered that yet. We will do in future lessons. And we've also done gravity die casting, where it's just poured into a mold, and we've also done pressure die casting. So we kind of combine those together a little bit, but we've done all of those. Now, you should hopefully have your processes booklet that I've been encouraging you to make notes and draw the diagrams and all those kind of things. But if somehow you've managed to completely misplace that or not make very good notes when you're in the lessons, if you go onto the VLE, you can also go into the R drive if you find it easier. Go into product design, so click on product design, then obviously click on A level, then go to the theory section and click on technical principles. So that's a whole section there about this exam basically, and there's also one for designing and making, the second paper. So that's paper 2 and this is paper 1. Okay, then if you click on technical principles, you get a lot of icons come up, but you will find one that says metal processes. And I've just now put all of the PowerPoints that we've been through in the lessons right at the top of this page. You've got to scroll past a couple of mind maps, but if you scroll down, you'll find all of the PowerPoints that we've gone through in the lessons, with the video links should be on them as well. So hopefully that's useful. If you do the same thing as well for polymer processes, you won't find quite so many PowerPoints. If you scroll right down to the bottom, there are some PowerPoints, but also there's diagrams and things. Remember as well, YouTube is your friend. So if you're not sure about any of these processes, just type into YouTube drop forging process, and you'll get a very exciting video with an amazing soundtrack showing you what drop forging is. So that's the metal processes. This one is the second thing on the revision guide, the revision list. So it's rapid prototyping. So on this page it starts here, and I kind of made a slight mistake. It also goes on to the next page, but I massively recommend that you watch this video that I made about rapid prototyping, and I've put that onto the task for this paper. So have a look at that. It's called A-Level Rapid Prototyping. Watch that video, because it takes you through not only this type of 3D printing, but something else, the metal 3D printing, as well as thinking about how it's impacting on like manufacturing, traditional manufacturing. So have a look at that, have a look at the video. The next one is basically just learning the ferrous and the non-ferrous metals. So these here, so aluminium, copper, zinc, silver, gold, titanium, and tin, those are the non-ferrous metals the exam board expects you to have an awareness of. So some of the properties and some of the uses. Try and get like 1 or 2 from each if you can. This is perfect flashcard territory. Like, I don't know how else you would do this. Maybe I would probably do a mind map with like lots of little sketches of like an aluminium can. That's a terrible little can, but you get the idea. That's just how my mind works. I like to sketch and doodle. You might want to make flashcards. It's totally up to you. So I've also done a very exciting video. This is on the task. Hopefully you've had a look at that. I'm sure it's absolutely scintillating, but it takes you through all of these and your ferrous metals that you need to know: low carbon steel, medium carbon steel, cast iron. Okay, those are the 3. For the exam, you do not need to know alloys. Okay, so quite a few of you asked me about alloys. You don't need to know them. You just need to know these 2. Also, just have a read of this page. It just gives you some interesting information about like stock forms of metals, some of the characteristics, why they're used, the different things and what it means. Just useful to have a quick read. Right, this one is something that we haven't really covered, and there is one question in the paper about this, but this is something really worthwhile you learning about now, and we can cover in future lessons. I've made a video about metal finishes. Please go and watch that. It goes through all of these different types of metal finishes, all the way from electroplating to powder coating to galvanizing, all of that sort of stuff. It takes you through all of that, as well as some of the more odd ones like anodizing, which is done on aluminium. And also this one's a really odd one. It's called cathodic protection. Any of you that did chemistry might know this. It's where you use a more reactive metal. It's like a sacrificial metal that would corrode before your actual product. So for example, things that are submerged in water like boats quite often use this type of protection to protect the hull of the boat. Okay, so have a read of these pages, but then I would also recommend that you have a look at the video, because there's more diagrams and I chit chat through it, hopefully give you a little bit of advice as well. Okay, smart materials. Again, there is a video about this. You need to know the different types, how they are influenced, what kind of stimuli actually get them to react. So it could be pressure, it could be light with photochromic pigments and things like that. It could be heat with thermochromic pigments. It could be shape memory alloy. So have a look at the video again, and have a look at these 2 pages in the revision guide. Right, this one is the one where I've been a little bit mean, and it's really hard to get these into your head. But knowing the different types of thermoplastics and thermosetting plastics, knowing at least a property of them, and if you really think about it, you can be quite clever with it, because with any thermoplastic, properties that you can say are things like suitable for injection molding, and quite often they're very lightweight. If it's a thermoplastic, it can be it can be recycled. So sometimes the properties are quite similar across all of them, but quite often they have something specific. So for example, polypropylene has got excellent fatigue resistance. Nylon is really good. It doesn't have much friction, so it's used in things like gears to replace metal gears because it's much more lightweight. So try and go through those and pick out something that's unique about the particular polymer. Also have a read of this page to give yourself an idea of like what these things actually mean. And again, there is a very exciting video for you to watch on the task for this paper, so have a look at that as well. This is just the second half of this. The thermoplastics that you need to know. Notice that they've always got weird and wacky names. The only one that I think you should be potentially confused by is polyester resin, because polypropylene, polyester, kind of sounds like it should be a thermoplastic, but it says resin, which should really give you an indication that it is a thermosetting. Okay, so make sure you know a use for each of those. I can tell you now there is no elastomers in the paper, but I would still recommend that you look at this. If you've looked at it already, that's good, because they are very popular in the exam. They're always coming up. They always love a elastomer. They're always in the exam, apart from this one. Okay, this one is something that we haven't covered very much. I'm going to do a video on this one, and I'll probably try and do that tomorrow. So keep a lookout for a video on enhancement of materials. Basically, these are things that you can do to materials to enhance their properties. So with polymers, you can add things into the actual polymer kind of makeup of the polymer. You can add things like fillers that basically just bulk it out a little bit, almost like sausages, where you bulk it out with like wheat and things like that. Pigments, obviously, to change the color. You can add something called a plasticizer, which makes it much more bendy and so, for example, more stretchy. Things like cling film would have a plasticizer in it to make it a bit more stretchy. And also things like UV light stabilizers. So you might, for example, put into a plastic that's outside a UV stabilizer to stop it degrading, okay, in the UV light. As well as that, we've got things like wood kind of finishes that you can add. Wood is very susceptible to things like rot and insect attack when it's left outside. So these are all completely common sense paints, stains, varnishes. But the one that you might want to have a look at in a little bit more detail is pressure treating, because that's a whole process, and I should have a video hopefully out tomorrow to help you with that in a little bit more detail. Okay, so have a good look at that. Right, the maths in the paper, I've been pretty nice to you. I've taken out the absolutely shocking maths question. I've left in one that requires you to be able to calculate the circumference of a circle. So I'm pretty sure that's pi d. You need to know the difference between a radius and a diameter. Hopefully you do on a circle. Radius is obviously into the middle, diameter is all the way across. And you also need to know how to calculate speed using the speed equals distance over time. So I always like using these triangle-y things. So speed equals distance over time. So for example, if you needed to find the time, it would be distance over speed. Is that right? I think so. If you needed to know the distance, it would be speed times time. So make sure that you are happy with this and you know how to calculate that. I'm not going to put together any revision stuff for the maths. Just see how you get on with it. It's always the same kind of maths. It's finding areas, it's finding You know, they love a little bit of, they like trig. There's no trig in this exam, in this paper anyway, pretty sure there isn't. So the math that's in there I don't think is too bad, but the one question asks a lot of you. So see how you get on with it. Okay, I'm going to try and whiz through these last ones. Standard components and bought-in components. There is a video on the VLE about this, and you've got a page in the exam, the revision guide, sorry, as well as something about sub-assemblies. So that might be something to read to get you thinking a little bit more A-level, because the video that I've done, that I've put on the VLE task, is actually a GCSE video, but it covers the basics of why manufacturers buy in standard components. So have a look at that video. Again, this is a big section that you need to have a good awareness of. So on the VLE again, there is loads of resources to help you with these in the same spot that I just showed you with the metal ones, but they're called polymer processes, surprise, surprise. YouTube is also your friend. And if you manage to keep your original manufacturing booklet, we did cover all of these. We covered all of these. I'm pretty sure we did anyway. Maybe we didn't cover lamination. I'm not sure we did actually. But we covered most of these in year 12. So have a look over these: vacuum forming, thermoforming, calendaring, line bending, injection molding, blow molding. Then you've got your rotational molding, extrusion, and I can tell you now there is no compression molding in the exam, just to give you a bit of a break on that one, because I'm not sure we've covered that one. So have a good look, make sure you are happy with diagrams and descriptions. So this might be a good plan to do some like kind of posters where you say the process at the top, you do a bit of a diagram of what the process looks like, you might draw some products that's used. On the side, you might do some steps. These would be great revision resources if you could do something like this. Okay, this one, polymer extraction and forming into a stock form. I did a whole lesson on this where I think I got step 3 and step 4 mixed up, sorry Bethan. But you've got literally, this is me being very nice to you. Okay, there you go. You can have that one on the house. Jigs and fixtures. I'm going to make a video about this. If you look at the rapid prototyping video, I do touch on jigs and fixtures. It's literally just this little bit here in the book, which is not the most helpful. So I'm going to do a little bit about manufacturing aids, specifically about jigs and fixtures, and I'll do a video to help you out with this one. This you should know really, really well. I'm hoping that you've done this quite a bit with Mr. Johnson. Finite element analysis. So where CAD can produce images like this, which would indicate where stress and forces are kind of concentrating on a product, enabling you to optimize the design, maybe remove material to make it more lightweight. So it's kind of simulating different forces through the use of CAD software. Again, look on YouTube if you want to make sure that you've got plenty that you can talk about. And the last one, I've been really nice to you again here because I've been very specific about the composite that I want you to know about. And the composite I want you to know about is carbon fiber. So there's only this amount in the actual book, but I've put together a video, which you may have seen before. I did it maybe a couple of years ago. And it does, I think it covers also glass, GRP, but if you look at the carbon fiber stuff, that is all really relevant for that. So I think it goes over quite a lot of different composites, but just pay attention to save you some time, unless you want to do extra revision. Just have a look at the carbon fiber stuff. Okay, I hope that was useful. I know that was almost 20 minutes long, but that's all of the kind of main bits that are in the paper. I'm hoping you feel like you've got enough resources. I'm going to put together some extra resources and additional stuff for paper 2 as well. So let me know. Can you please send me an email if you're worried about anything or want any additional resources? I completely forgot to say at the beginning of the video, if you are still here, I hope you had an amazing Christmas and I hope you had a really nice time with your family, and Happy New Year. So I'm really sorry, I should have said that right at the beginning of the video. But Good luck with the exam. Come and let me know what you think of it when you've completed it, and I'll see you in a couple of weeks' time.